Okay, so let's look at a very high level of the general features of functional programming in JavaScript. First of all, you can have global functions, functions at the top level, not just functions that are attached to objects, which other languages call methods. In contrast to many other mainstream languages, when you declare a function, you don't declare types. You don't say that x, the input to Square, is a number, and you don't say that the thing that you're returning is a number. It just happens to be a number. Whether this is good or bad is a matter of extremely fierce debate, but nevertheless, that's the way it is in JavaScript. JavaScript is a dynamically typed language. It figures out the types at runtime, not a statically typed language where it figures out the types at compile time. An odd feature of JavaScript is you can declare a function to take one argument, but then you can call it with two arguments. And the second argument perhaps is ignored, or as we'll see later, can be captured with some code inside. Or you can call it with no arguments. And so that's a little bit odd. It's not usually a good thing to make use of this, but nevertheless, it's something that JavaScript supports. The main point of this entire lecture is functions are first-class data types. Another way of saying this is functions are just as important and just as general purpose as numbers and strings. So the kinds of things that you can do with numbers and strings, you can also do with functions. You can pass them around, you can assign them variables, you can stick them in arrays, you can put them in objects, you can return them, and so forth. And most of this lecture will be spent looking at what I mean when I say functions are first-class data types. And then we'll also see that you can create anonymous functions. You can make functions that are not assigned to variables. And this, especially functions that capture local variables, which are called closures, is critical for doing AJAX, calling to the server and getting a value back and inserting it into the page. Now, we'll be using jQuery, which does this closure behind the scenes, but nevertheless, it'll be quite common even with jQuery for us to make these sorts of closures, anonymous functions that incorporate a local variable, when we do AJAX programming later in this video series. When you say that functions are first-class data types, what you mean is that you can do the same general sorts of operations with functions as you can with other data types, like, for instance, numbers and strings. So in this section, I want to look at two things: the fact that you can assign functions to variables, and that you can put functions in arrays or other data structures. In later sections, we'll look at some other features as well. Okay, let's illustrate these ideas in Firebug. So I bring up a page that I created, I open Firebug, and I will define a function. Function square of x, return x times x. Okay, there's a function we've seen several times before. And just to test it out to make sure it works, let's call square of 5. Sure enough, I get 25. So the first thing I want to illustrate is that you can assign functions to variables. After all, you can assign numbers and strings to variables. Why not functions? So when I define a function, it really already has a variable. The variable is called square, and its value is a function, but I could assign this to another variable. So I could say var f equals square. Not square parentheses with some arguments. That would be a function call, but just square itself. That's the function object. And so now f points in memory at the same function as the square variable. So the square variable and the f variable point at the same thing and can be used in the same way. So I can now say f of 10, and I get 100. Or I can say square of 10 and get 100. So I took the function I originally created with the function operator square, and I assigned it to a different variable f, no problem, just like you can with numbers. You can also put functions into arrays. So let's define another function, function double of x, return x times 2. You run that. Let me make sure it works. Double of 10. And sure enough, I get 20. So now I can make an array. Var funcs equals, remember use square brackets for arrays. I can put square in the array. I can put f in the array. I can put double in the array. Notice I don't have parentheses. That would be a function call. I just use the variable, the name of the function. That's the function object. And now that they're in an array, I can get some things out of the array. So I can say var my funct equals funcs sub 1. That would be f. And I can say my funct applied to 20. And sure enough, it squares and gets 200. But there was no reason I had to assign it to a variable in between. So instead of saying my funct, I could have just said funcs sub 1 applied to 20 and got the same thing. So I could index directly into the array and then supply arguments to that function. I didn't have to assign it to a variable in between. And you can not just put functions in arrays, you can put functions in other data structures. Now, we haven't covered objects yet. They're coming up in the next section. But here's a really quick example. Var sum object equals, and objects, you use curly braces instead of square brackets, and you give the property name and then a colon and then the value. So it'll have a property called A, whose value is 1, a property called B, whose value is hello, and a property called C, whose value is square. Again, no parentheses after square. It's the square function, not the function call that returns a number. We haven't really covered this in text, but you can get the idea, the basic idea of it now. Sum object dot A, that returns 1. Sum object dot B, that returns hello. Sum object dot C would return the function object, or I could then call it on 5 and get 25. So you can assign functions to variables. You can put functions in arrays. You can put functions in other data structures, just like you can with numbers and strings.